Hey kids, Flexing Teacher Weber here. We're going to start a new unit today. Sort of a new unit. It's going to connect to the last unit that we did on squares and square numbers. We're going to start investigating right triangles today, and we're going to connect right triangles to squares. Now what I have here is a right triangle. A right triangle is a triangle with a 90-degree angle. Now a 90-degree angle is on this triangle down here, and you can tell it's a 90-degree angle. Normally they're indicated because they have a little square in the corner. And that angle would be 90 degrees. Now, what does 90 degrees mean? It means that that angle makes an L shape. So that's a 90-degree angle, and a right triangle has one 90-degree angle. Now, the sides opposite, or the sides beside that 90-degree angle, so this side right here and this side right here, they have a name. They're called legs. So I'm going to label that on there. That's called a leg. And that's called a leg. And then this is really important. The side opposite the right angle, so this side right here, is called the hypotenuse. And it is the longest side of the right triangle. So we've got a 90-degree angle. The sides beside the 90-degree angle are called the legs, and the side opposite the 90-degree angle is called the hypotenuse. Now, what we're going to do today is we're going to do basically an activity where you do some counting and discovering of area of some squares, and you're going to connect that to right triangles. So I'm going to flip forward to this page, and you can see this page has the information we just talked about right triangles. But we're going to do activity 1 together right now. And activity 1 says, the area of a square drawn in a grid can be calculated by dividing the square into right triangles, and in some cases, a smaller square. Determine each area by counting the squares on a grid. Compare your method to your classmates. Well, we're not going to be comparing to a classmate. But let's take a look at number 1. And what we're going to do is we're going to calculate the area of these squares. Basically, that means we're going to count the number of little squares that make up the big square. Now, we could just count this. We could just do this. If I was to calculate the area of number 1, I could say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I have to worry about the little half squares. This makes 13, these two make 14, 15, these two make 16, these two make 17, and these two make 18. So I would say the area of this square is 18. But it can get tricky as we start to count squares that aren't halves but quarters or thirds. It can be tricky to count. So there's a better way, and that way is using right triangles. So if you look at this, if you look at this square, it's divided into 4 right triangles, right? There's one there, one there, and one there. So it's divided into 4 right triangles. Now I'm going to draw a little addition to the square. I'm going to do this. I'm going to say doink, doink. Look at that. Now when I do that, I've created a square, and that square is made up of 2 of these right triangles. So when I do that, when I make that square, here's all I have to do. Now I've got 2 of those right triangles together making up a full square, and I've got it, it's all made up of little mini squares, right? So I can say there's 1, 2, 3, 4, 5, 6, 7, 8, 9 mini squares in those 2 right triangles. And since there's 4 right triangles altogether, I can say 9 times 2 equals 18. And that's another way I could get the area of this without having to count the little half squares. Okay, let's look at another one. Number 2. So I want to calculate the area of this full square. I could just do this. There's 1, 2, 3, 4. This makes 5, this makes 6, this makes 7, this makes 8. So I'd say the area of this square is 8. But I could also do this. Look at this. I'm going to draw this addition on. And what I've got now is I've got two of the right triangles. There's one, there's another. So I've got two of the right triangles, I've put them together and I get a square. And this way I don't have to count up half squares. All I've got to do is this. There are 1, 2, 3, 4 squares in those two right triangles. So you'd say in these two right triangles there are 4 squares. 4 mini squares. That's for half of the full square, so double it, and you get 8. Okay, let's take a look at number 3. So we got a big square there. It's made up of 4 right triangles, 1, 2, 3, 4. I'm going to take one of those right triangles and I'm going to connect it on the top like that. And now what I have here in this full square that I've made that full square with 2 of the right triangles. So now if I want to calculate the area of this thing, I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 2 of those right triangles have 16 squares. So 4 of them would be double. So the area of this full square is 32. There's 32 little squares that make up the big one. Okay, check this one out. It's a little bit different now, and this is where it would be really hard to just count up half squares, because how much is that one? How much is this one? So do this. I'm going to connect this like that. Oops, I'll draw a better one. And what I've done now is I've got 2 of the right triangles from this diagram have come together to make a rectangle. And so I'm going to count 1, 2, 3 full squares. So 2 of these rectangles make 3. Now there's 4 of those rectangles, there's 4 of those triangles all together, so I'm going to double it, and that's 6. And then I'm going to add those 4 in the middle, this, and that's going to tell me that the area of this full square is 10. And I don't have to count up small pieces of little squares to get that. Okay, let's do a couple more of these. So over here, number 5. To count up the area of this full square, I'm going to do this. And now what I've done is I've taken 2 of the right triangles and I've put them together to make a rectangle. So when I count up the area of this rectangle that I've made, it will represent 2 of these right triangles. So 1, 2, 3, 4, 5, 6. So 2 of them are 6. There's 4 of them, so I've got to double it. That's 12. Plus I've got that one little guy in the middle there, right? So I'm going to add that one little guy on, and I get 13. The area of that guy is 13. Okay, take a look at this one. Again, there's 4 right triangles there. I'm going to connect one of those right triangles to another one. So I'm going to do this. I'll just draw it a little bit better. Okay, and now I've got 2 of the right triangles from this diagram have come together to make a rectangle. So 2 of those right triangles, when I count up this rectangle, that will be 2 of those triangles. So 1, 2, 3, 4, 5, 6, 7, 8. 2 of them makes 8. 4 of them I'd have to double, so that's 16. Plus the 4 in the middle. That means the area of this one is 20. Okay, let's take a look at 7. Again, 7 has 4 right triangles. I'm going to take one of those right triangles and connect it. So now two of those right triangles make a rectangle. Count the area of that rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So two of them make 12. To get four of the right triangles, I'd have to double it. That's 24. Plus, there's one in the middle. So plus that one in the middle, and that makes 25. Okay, last one. Again, this square has been divided into four right triangles. I'm going to take one of those right triangles and connect it on the hypotenuse, and I get a rectangle. So that rectangle I've made represents two of the triangles. And I'm going to count up the mini squares in that rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Two of the right triangles represent 15. Four of them would be double that, so that's 30, plus the 4 in the middle. And the area of that guy is 34. So that's how we can use right triangles to count up the area of squares. Now in the next video, you're going to have to use this idea to do a little investigation into right triangles. And that's going to be the activity you're going to do today. So I'm going to have one more video on this that will apply this idea that we've just learned. Flexing Teacher Weber, out.